Good morning, everybody. You made it all the way to Friday. Probably only a few hangovers in here. This is only my second time in Australia, but I know you guys do hangovers better than anybody in the world. My name's Ned Pyle. I'm a program manager and Windows Server at Microsoft. If my name sounds slightly familiar, you might have read stuff I wrote on AskDS blog. That's my main sort of like public persona over the many years I've been at Microsoft. 9 years now at Microsoft. About a year ago, I switched from being in the field areas and support to being in Windows Server as a organization. So I helped design parts of File Server, and we'll see how well we did this time. This was my first shot. If you went to the DFSR presentation, you saw a lot of the work I did over the last year. The team I'm on is called File Server Foundation, which means that I own a lot more than just DFSR. I own parts of SMB. I own the entire information worker as a thing, which theoretically is some of your customers or you. And today, I don't know if anybody's ever managed to get out here from our group in the last 2 OS releases to talk about SMB3 and scale-out file server. Do we ever get to TechEd with a PM? No? All right. Well, hopefully this is news to you. So I'm going to talk about SMB3. I'm going to talk a lot about Windows File Server and SMB3 and a lot of things that aren't necessarily SMB3, a lot of big features pieces. What's new? I'm going to go back and go over 2012 again because it's still really new. When we put out an OS not even a year ago, here comes another OS. You can see we've picked up the pace quite a bit. I'm going to talk about what we changed in R2 for SMB3, which is not much. But if you haven't learned all this stuff from 2012, it's still going to be a gigantic deluge of information for you. Then I'm going to talk about what we could do with this thing in real life. We'll talk about some troubleshooting. Not that we need to troubleshoot SMB. It's perfect. Just in case. Solar flares do happen. Okay, so why are we even in here? You all know in SMB it's been around for 1 million, billion, zillion years, right? It's actually older than Windows. It's Landman. I mean, technically IBM did some of the first work on it. We did work with OS2 with IBM. All the way through XP, that was SMB1. And then we had Vista and 2008. I haven't been out of the field that long. SMB2, a lot of great ideas, not necessarily the best implementation. SMB 2.1, where things really got together, really good release, faster, more manageable, a lot of good capabilities, but still very much client-server enterprise related. That was Windows 7 and 2008 R2. And I even have a section in here about 2.1. I don't forget about it. My main job as a new program manager coming from the field that my boss told me was to make sure that they understood that there's a world out there that uses the products that we have shipped, not the one that we shipped 5 minutes ago. We're always thinking in terms of the OS that we can't even talk about. The one that just 8.1 has been legacy for months. So I'm here to kind of keep things grounded with that team, hopefully. And then 3.0 came with Windows 8 and 2012. And then we just did a tiny point release here with R2 that I'll talk about in more detail. And the way to look at it is like this. If you can't remember anything else. And along those lines, I don't have a slide on it because it's one of those things that almost nobody can ever do, but you can actually remove SMB1 now if you want. You can uninstall it, and it will work, unless you need SMB1. It's a good way to find out. It's better than any auditing. Okay, so 2012 was a gigantic change for Windows Server. It was a gigantic change for File Server. We really had been sort of sitting on our butts for a long time on File Server. You know, things hadn't changed dramatically from NT. 2000 added a lot of stuff that wasn't really new to File Server, and 2003 added a lot of new stuff that wasn't new to File Server. Until 2012, we hadn't really reevaluated too much about File Server. So we had this whole plan in our heads, right? We're going to change the game on this. We're going to start competing and cooperating and duking it out really in the storage market really for the first time. Seriously. Not in the work group server kind of way. Maybe not even the enterprise where we're replicating data kind of way, but like with the big players. And we're going to do this by separating out everything. Compute, Hyper-V, SQL, apps, whatever. Storage, its own entities, its own units. We start making clusters in a box. We start having, the ability for hosters of cloud stuff or companies who are big or small who want to just scale with units. We tie it all together with a really inexpensive network like SMB3. Even when we're using the specialty hardware I'll talk about, like for RDMA, still super cheap, but great performance, full stop, not just for the money, great performance. And then really inexpensive, more commodity-like storage. Now I know who here is using storage spaces and JBODs yet? That's about what I expected. Who here is using SANs? All right. We know that we've got a battle, right? That's why I'm in the room. It's not to convince you, but just to show you got options now. We're realistic about this. We know it's going to be a while. So this design, this required us to put together a whole new stack, all this stuff, ODX and storage spaces, like our own version of RAID and, VHD stuff out the wazoo and Hyper-V here and Hyper-V there, and management APIs and NFS. I mean, a version of NFS 4.1, which is actually more state-of-the-art than the ones that go on Unix usually. That's how serious we were about getting into this. But for today, two things, SMB3 and what we call the scale-out file server. And we'll talk about the traditional file server as well. I'm not going to let that one dangle away. You've got another 10 years of that bad boy at least. So, what's the whole point of SMB3? We spent a lot of work. We basically stopped what we were doing for 3 years. Remember when DFSR stopped being developed for like a whole OS? And DFSN kind of stopped being developed. Like everything stopped being developed except suddenly all this stuff came out. It's because everybody on that team stopped working on everything except this. It wasn't like we had given up on those things. We only had so many developers and testers. So we want to enable this infrastructure as a service, scenario, blah, blah, blah. We want to be like kind of the go-to protocol for file transfer. We don't want to crush iSCSI and NFS, but we want to be the one that people want to use, SMB. And we want to modernize ourselves for information workers. I'm going to talk a lot about stuff that you're going to hear cloud people talk about. I'm not for or against cloud. I'm in it. But I'm definitely for information worker, because that's the one that makes lots of money for my company. Tons. I love it. I love information. I spent my whole career in information worker. So I'm not going to forget about it, and we're not going to forget about it either, strategy-wise. We may talk a lot about cloud, but we're not forgetting about the stuff that runs the world right now on Windows. So, have we convinced anybody else besides ourselves? Well, EMC and NetApp now have SMB2 and almost all of SMB3 implemented now, either in VNX, VNXC, ONTAP 8.2. There's SMB3 all over the place now. And they have their commitment to finish adding all the features they think they need. Even Apple, who would not spit on me if I was on fire, believes in SMB2 now. Maverick, that's the primary file protocol now. No longer Apple Talk, Apple File Protocol, whatever it's called, except for one of their features. Okay. Let's talk about file server just day to day. And what time does this thing end? 11? I'm a terrible presenter, you're going to find really fast. I don't know how long I'm supposed to go. I get into rambling stuff like I'm doing right now. File server cluster. Who here runs file server clusters already? Okay. Anybody doing it for applications? 1. SQL? Couple? Is it SQL or some third-party app maybe? Mostly SQL? Okay. Do you use scale-out file server or do you use regular file server? Regular? So what happens if one of the cluster nodes dies? It's a hiccup. You might have to restart the SQL instance, pretty much have to restart the SQL instance. And otherwise I wouldn't be talking here right now about a feature that lets you not have to restart the SQL instance. So right now it's, with 2012 SQL and with Hyper-V and with other products, you're allowed to point to shares. VHDX on a share, SQL database and logs and all that good stuff on a share. That's been there for years now. But if you actually try to use this on a cluster, the instant you fail over and those connections close and those handles die, that application is not expecting anything to ever go away. That application was written by a developer who wrote everything and tested it all on one machine talking to itself. I guarantee it. And that means that you have to step in and do something. And even if you're the smallest, if you're a dentist's office with 3 people working there, stepping in to do stuff on an application workload is never good. There's a long period of trying to figure out what's going on, what happened. Oh, wait, the node failed? Oh, why do we have a cluster if failing over the cluster doesn't fail over the... Okay, this is terrible. I hate Microsoft. I hate Ned. So what we decided to do was encourage people to put their workloads on clusters. Clusters are good. Lots of cluster means high availability. Lots of cluster means one node dies, or you need to patch a node on Tuesday for some reason, or something like that. Other nodes can keep working. That's fine. So we decided, let's have Hyper-V use SMB3. That's going to become its protocol of choice. We're going to put our VHDXs on file servers, on other clusters probably. Connect through them. Do the same with SQL. Have as many instances as you want. Put all the backends on some file server. Separate it all out. That way you can scale up storage, scale up SQL, not have to have the same people necessarily with their grubby little paws all over each one, with or without the knowledge to maintain them. I mean, I wouldn't expect a SQL developer to manage a file server any more than the other way around. There's nothing wrong with that. It's just we have separate skills. So it makes me more flexible, easier to provision. I kind of got myself ahead here. Theoretically, it's cheaper. I don't know, probably cheaper, maybe cheaper. It's certainly cheaper with our implementation to set it up, because we're going to be, once you see how we do these things, we use considerably less expensive hardware barrier of entry. And I don't want to talk ill of all the storage vendors and stuff, but I think generally speaking, we can just be cheaper with the software side as well. So, that's a lot of marketing stuff, right? Let's talk about the reality of it. Part 1 is transparent failover. SMB and what we call continuous availability, or we have a million names for this, but what it boils down to is we want to make it so that I can run an application workload on some set of clients, aka some other servers, and have them talk to a storage cluster, and when the storage cluster has a failover on purpose or inadvertent, that application doesn't even know. He sees a brief stall in I/O, maybe a few seconds, and then he's magically connected again. He's like, oh, that was weird. I'll just keep working. We do this so we can support planned and unplanned failover and load balancing. And we make it resilient using something called the witness. So starting in Windows 8 or 2012, and forever probably, we actually are keeping, well, let me ask you this question. If I cut the network to a node, how long should it take TCP to figure out something's wrong? Usually. Any guesses? It's like 10, 20 seconds. Like he's sitting there trying stuff and like, is anybody there? I'm not sure. Which is fine because it's designed to be really resilient, right, over bad networks. Well, in this case, this is probably going to be a pretty good network. We're talking about a LAN, some machines probably 20 feet away from each other. So what we have is a client and a server piece called the witness that use RPC, not SMB. who keep track of your connectivity to servers and tell the clients, hey, this cluster knows about all these nodes. I'm a cluster. And one of my nodes just died, so I want you to connect to this node. And just go right now. I found out about it within, a few milliseconds. Don't wait for TCP to tell you that things aren't working. They're not working, trust me. Connect over here. So it requires a failover cluster. It requires 2012 or later. These slides are kind of a mashup of old and new, so every once in a while I forget to say or later, sorry. And this, what gives us this continuous availability is basically just saying that I'm going to queue up all this, and the application doesn't know about any of this. Only the SMB client, only the SMB server, only the witness client, and only the witness server. And the IOs just back up enough on the client, it's just SMB just queuing stuff, that by the time it fails over and it pumps it all through, the application should not have noticed any issues. We can actually take up to 60 seconds to fail everything over, which both SQL and Hyper-V will be like, oh, that's weird, but okay, I'm working fine. But we won't take 60 seconds. We'll usually go really, really fast. Okay. This also requires us to do something really cool called scale out. So I've got all these nodes, and in the past, having lots and lots of nodes really meant having lots and lots of servers each doing one thing, right? We didn't have the idea of active in Windows Server, not really. You might have some nodes doing some stuff and some nodes doing some other stuff, and then if you failed it over, one node's doing everything, but that's not really active. With scale out and using a cluster shared volume, CSV2, we are actually truly being active. We are hosting the share across all the nodes and directing the data into the appropriate actual piece of storage owned by whatever that node is. You can do this with a lot of nodes. In our case, with cluster, we support up to 8 file server clusters, so we support up to 8. And I don't recall if that's actually even a real limit or just us saying, like, okay, we tested to 8, that should be plenty. But it means active shares. It means zero downtime because none of the shares could ever go away. They're always active on some node, always. Failures recovery will recover from what? Everybody's active, everybody's working. Support for RDMA, a lot of things I'm going to get to in a little bit here. This is really designed for server apps again, Hyper-V, SQL Server. For applications that do not want the slightest bit of interruption. I mean, something like SQL is basically writing to a file, so to speak. When the server instance is writing to its database, it's writing to a file. And that file is just sort of being appended to, for the most part, and growing and growing and growing. And we're never really closing the file. It's open for days, for weeks, for months, theoretically. Whereas a user opens a file, Word, it's not really even open most of the time. Usually some auto-recover file is the one that they're using, or some temporary file. It writes the whole file all over again. The file's not that big. It's never really open all that much. They're okay. And I'll talk about more about when you should use scale out and when you should not. But this is really designed for, and you'll see, you'll desire to use it with app workloads, not with users. It will actually be much slower for your users to use this. Regular, traditional information worker users. I'll talk about why in a little bit. Okay, the next piece is SMB Direct, or RDMA. This is basically our competition with host bus adapters, right? Anybody using RDMA yet? Oh man, not even one? God, I thought I'd get one of you, one cheerleader in the audience. All right. There's a number of manufacturers who make these. You'll see the various types to iWarp, Rocky, InfiniBand. Mellanox and Chelsea and Intel make them. They're not expensive. They're of various costs, but they're considerably less expensive than HBAs for the most part. And they give you the same capabilities. Super high bandwidth or throughput, very low latency, And your machine that's running them will have very low CPU because they are NICs with CPUs on them, doing most of the work through RSS, through offloading, through their own little tiny brains. It gives you load balancing, automatic failover. We have multi-channel that I'll get to in a second. But what it means is, between those two R NICs down there, I could be pushing 40, 56 gigabit per second per port. Massive bandwidth. It's not something you put between a user and their server. It's something you put between a compute node and a storage node. You need these special kinds of NICs. And here's a little rough estimation of the performance compared to the equivalent, SAS, HBAs, or fiber channel, where we can go as high as 6.5 gigabytes per second, which is a lot faster, even though it's less expensive. Has anybody tried evaluating these yet, at least, or just no, nothing? Is this the first you're hearing of it? Kill all of our marketing people, kill them. Okay, is this being recorded? Oh. I love the marketing people. If Prabhu is listening to this, I'm sorry, sir. Okay. Okay. One of the things that it uses, which is something that you can actually use without RDMA, you can use on your own workloads right now, is something called SMB multi-channel. This allows you to get insane throughput or bandwidth aggregation or whatever you like to get more and more of your pipe in use, or pipes. It is turned on by default. It figures it out by default. You can control it with PowerShell, tune it up, turn it off if you like. We'd prefer that you not, but you can. It will use NIC teaming. Doesn't require it, though. It figures out the failures all by itself. It's a clever little guy. In fact, it's so good, it's masked bugs we've found over time. We have to be really careful using it because sometimes we'll see problems, on some connections. And if we're just watching the overall workload, it's working fine because multi-channel is hiding stuff because it's so fast and so good. It needs, at least one of these, obviously multiple network adapters for multiple channels, or one or more NICs that support RSS, or one or more NICs with teaming, or one or more NICs that do RDMA. And you can see on our little not super awesome diagram there how you can see these tied together. When I say SMB client, I'm probably talking about another server talking to yet another server, right? We're talking architecture, not SKU, not client OS. You could use these on a client, but how much bandwidth does somebody need to run, Excel? We finally added SMB encryption in 3.0. Using AES CCM, we actually completely protect the data in flight all the way across. This is only first available in SMB 3. Until then, what do we have? We had signing. What does signing get me? It lets me avoid tampering with packet. I can tell that it got there and nobody messed with it, theoretically. But it doesn't protect the data from being looked at. Now, SMB encryption is maybe not something you turn on when you're doing things like scale-out file server. This is one of those features which is probably more information worker-centric. In fact, it's even more, maybe even branch office-centric, where you're going over, say, MPL. Do they have MPLS networks in Australia? Yeah, okay. I never know what the wacky standards are around the world. I'm not that smart. If you're going over some network that you're not really confident that you control it end-to-end, if it's going through some ISP who's saying, we guarantee everything, the NSA will not be examining your data, I promise. This is something you can look at. And we even did it with an encryption algorithm that we could leverage AES-NI, which is a processor extension that Intel has on all Nehalem and later, basically the second version of Nehalem and later. It's about 5 years ago when these things became available. So if you bought a machine in the last 5 years, you have acceleration for this. That means you could turn it on and see, and I don't have a good solid chart or numbers for you to give you, but quite a bit less degradation than you should if you don't have it. If you don't have it, I can tell you it will get really slow. Super duper slow. You can configure it per share. You can configure it for the whole server. You can guarantee that only SMB3 machines show up. Nobody else can connect. Another good reason to get rid of SMB1. If you don't have it, why have it sitting out there? Great for WANs, great for branch offices. So this is one of our second examples of where we have not given up on standard enterprise computing. So all this stuff, all these things is just a lot of big words, right? Let me see if I can show you something interesting. What is this, 2? You still hear me okay? I'm getting caught on my cord. Is that all right? Okay. Wake up. And you have to bear with me because I'm using this as my monitor. You guys can still hear me, right? Okay, good. Hey, I can't type my password. Okay. So what I have here is a bunch of servers. This one I'm on right here, VM5, is my application data server. It's my SQL server. And I have a cluster here called Demo A. And if you want to run through these demos, we have them up. Anybody know Jose Barreto? Yes. He has this entire demo up on his blog. I shamelessly stole it. He's on my team, so what's he going to do? Although he is much bigger than me, so I don't know. So right here, I've got a 2-node cluster. I actually have another node sitting there ready to do some stuff. And these guys are using a cool new feature, which you can't really tell too easily, but you see that little batch file right there? They're using shared VHDX. So they're using they're a guest cluster using a set of shared VHDX files. That's new to 2012 R2. So you don't have to do all this wacky, through sort of provisioning of storage. You can just have VHDXs that are shared by multiple cluster nodes. They don't care. I won't be talking about that too much because that's like black magic to me, but if there might even be a session on it, I don't know. And this is pool of data. So that's the cluster view. Now over here, this is SQL I/O. And SQL I/O is a little application that we released 1,000 billion years ago that you can download from downloadmicrosoft.com. It just pretends to be sort of like a SQL application running as a little executable. Talking to, if anybody can read it, these test files that I have scattered across these map drives. And those map drives are hosted on my scale-out file server, on my cluster. And I've got 2 nodes. These are just scattered around. If you look on the client that I'm on, you'll see he's got a bunch of map drives. Not too interesting. There's the test file. And what I'm doing is I'm sending 8K IOs reading from these files. So I'm like a database where I'm just reading data, all the time. All this is a simulation because I don't know about you, I don't like setting up SQL Server. So I'm just going to do it the easy way. This is my SQL Server. And back here, over here, on the wrong screen, those are all my VMs running. Not doing too much. Okay. Now, let's take a look at this. If I can figure out which screen I'm on. There's perfmon. Now, I had this perfmon counter set up. Let me see if I can scale this a little bit. Just a little bit. Is that better? No. Not enough. that. I'm just going to cheat. All right. Little blips. All that shows, if you can read it, is data bytes per second. That's just me reading all of those test files on the shares. I'm going to pop these up just a little bit bigger at least so you can see something. There we go. Did I only do one? Am I that big of an idiot? You bet I am. There we go. Okay. So, I've got 2 nodes. They're working. This PowerShell command, get cluster shared volume, shows me that there's 2 servers that own these CSV nodes right now, 1 and 2. Of course, they both own it. It's active. They own all the shares. They're accepting all the IOs. They're redirecting all the traffic. Let's do this. Let me add another node. Come on, little guy. The best part of any demo, the waiting for the thing to do what it's supposed to do. There we go. Okay. This is a laptop. I mean, give me a little break here, right? I'm running 5 VMs on this hunk of third-party software. I won't talk about the hardware. It's validating this cluster. It's adding this node. I'm going to keep going. I'm going to switch back here and talk a little bit. We're going to cut back to this in a second, and you'll show you what happened. So let me do this. There we go. What it's doing is it's doing automatic rebalancing. We'll see it in a second. It's saying all of our clients will get redirected to the best possible nodes. If we add new nodes, everything will be balanced out. So if I keep adding nodes to this, or if I take one offline, I take 10 of them offline out of, I take 4 out of 4 offline. 4 out of 4. I patch them for Patch Tuesday. I run clusterware updating. I do whatever I want to do. Once I add them back in, once I bring them back online, I don't have to do anything else. All the load of all the users, all those apps will just get rebalanced across so that not one node is any slower or faster. You're basically saying every node I add is more compute power for storage and more network. So it's like multi-channel noding now that we have active-active. This is something new to Windows. I mean, lots of other things. There have been active-active clusters out there for decades. It's new for us. But really it means scaling up these nodes, adding lots more nodes, taking them offline, one of them dies, everything balances automatically. You don't have to do anything at all. All thanks to CSV. And these connections are managed per share, and as the CSV moves around or as it gets owned by some other node, everything moves with it, all automatically. You don't have to do anything. So let's see if anything exciting has happened over here while I was talking. 2. Okay, it added the node. It's still thinking over here. Within about 2.5 minutes, we'll start seeing traffic on the third one, just through magic. Let's see if we can see anything else owned yet. Not yet. When I run this again, a minute or 2 from now, we'll see that demo server 3 is now part of this. He probably owns at least 1, maybe 2 of the CSVs, and he's cranking stuff along. Let's see if he's done anything yet. Not yet. Oh, is it scale? Maybe, you think? I don't know. I haven't seen it actually switch this over yet. change the scale just to be smart about it. Oh, timing looks good. Now that's a little crazy. Let's scale the counter. Oh, now there's 3 if you can read it. So I added a server. I could add more servers, more and more and more servers, right in the middle of the afternoon. No one will know except suddenly their workloads will seem to get faster. Take some of these offline, do maintenance. It's got crazy disk problems. I don't care. Turn it off. Let the storage go somewhere else. Let the load go by itself. I don't have to do anything. I don't know squat about clustered, guys. I'm not a cluster guy. This is easy enough that I can do it. How about this? Oh no. Oh no, I'm going to kill it. Oh, it died. That node died. Whoops. I can't even remember what that says. There we go. It's fine. Now 3 is owning the rest. I turned that machine off violently. I hit the power button. I tripped over the cable. It's that simple. That's a SQL application running right there, right? Hasn't complained a bit. Still doing his little 8K IOs forever, happy as a clam. Okay. Now, what else do we do in R2 to make life better? We kept working on SMB Direct. The guy who works on SMB Direct is a guy named Greg Kramer. He is like a little elf. He's even shorter than me. He's got a little elfin beard and little pointy ears. I'm not kidding. He's from Ohio. They're a little inbred in Ohio. I don't know if you know how that is out there. And all he does all day long is think about how to make SMB faster and more secure. So he's, not the guy you want to hang out with at a cocktail party. But he sits there and thinks very hard with his little PhD in computer science, in artificial intelligence brain, thinking about how to make it faster. So just between 2012 and R2, he managed to make RDMA half again faster, up to 450,000 IOs per second from 300 per interface. He managed to optimize 1 million things with InfiniBand, with 40 gigabit Ethernet, getting way more density for SQL or for VM workloads. That's all he spent the last year doing. That's it. So between 2012 and R2, you can be half again as fast just by upgrading the OS and doing nothing else. The next thing, Hyper-V live migration over SMB. Who here is using Hyper-V? Lots of people. Yay. Who here is using VMware? No, boo. Okay. All right. It's okay. There's nothing wrong with VMware. They got us off our butts. No doubt about it. SMB is now the preferred transport for doing live migrations. Using SMB Direct or SMB multi-channel, super high bandwidth, super low latency, and no CPU overhead. When you do live migration with the old-fashioned way, TCP, there's a time of 60 seconds for whatever that was to fail over, right? With compression in Hyper-V, it's much, much faster, but the CPU overhead is really quite high on the hypervisor. With SMB with RDMA, it's still faster, and there's no overhead. It's the no-lose situation. Now, to do all this, we had to say to ourselves, well, we're using SMB a lot, and there's only so much network. We start thinking about how we control some of this bandwidth. Now, don't get excited. We did not do QoS. We did not do any sort of heuristic or, give me 20% for this and 50% for that and 30% for that and give me 10% extra in a case. None of that. This is, well, by default, all bets are off. Use the bandwidth that you can use. But if you want to manage it, we have some PowerShell commands. Very simple. It's like a set SMB bandwidth, I think. It's fairly guessable. And you can sort of define, all right, so for default, aka just random SMB traffic, I want to allow this number of bytes per second. So it's not a percentage, it's bytes per second. You'll have to do the math on how much bandwidth you have, right? We also have it set aside for virtual machine, like VHD, as the VHDX is the storage and the hypervisor is connecting to it, that kind of bandwidth, or for live migration. There's a not great diagram to go with it. And we added multiple SMB instances. So what this means is we've got several instances of the, as you can see, the server and the client, where it's figuring out amongst itself who needs to go to what actual storage. This, rather irritatingly, did not happen in 2012. So there's a lot of sort of redirection and metadata time. We sit there and think about, well, you disconnected, maybe you should go here, there, and figure it out. Now, we do it under the covers, internode only, and just for the metadata parts, the chatty parts. Some unexciting stuff. What it basically boils down to is there's some bugs that came out of this not being a feature. This resolves those. And it means we scale better. You can add lots more nodes, which is where the 8 node number may no longer matter. But I don't have an official answer on that. Okay. A couple of slides where if you've started to doze, these are ones to pay attention to. 2 in a row. Hyper-V using scale-out file server and all that stuff, SMB3 only. You can do this without using Windows storage. You can run your Hyper-V hosts with a backend over SMB3 of EMC, NetApp. I'm sure that Sambo will get there. I know they're working on stuff because they come around and chat with me sometimes. All those, vendors. If you're running Hyper-V, we're not as happy as if you're running Hyper-V and file server, but half a buck's better than nothing. And the BPA for Hyper-V will actually confirm this and, let you know if you're doing things right or wrong. You need Active Directory. You should use what are called continuously available shares. I talked about scale out and transparent failover before. Continuously available shares just means that the share supports being able to handle failovers. You can manage it with VMM, 2012 or later. You have to have the file server and Hyper-V on different servers. They can't all smash it all up into one machine. And if using failover clusters, they must be separate clusters. Okay. One other super important thing, and then I'll get into some other stuff. IW is information worker. SOFS is scale-out file server. Scale-out, I've said this a few times before, I'm going to say it again, is for app data workloads. The actual original internal name was called SODA, Scale-out Data Application. We still sometimes say it without thinking. But it means long-running ops, very little metadata. It has a write-through requirement. Anybody know what write-through is? You want to shout it out? Guarantee that it's on the disk. Guarantee that we're done, it's on the disk. If I lose power now, who cares? That is slower. Now, if you're doing it with a gigantic long-running I/O, you're tuning other things, and you're trying to use caches and some other stuff, it's not that much slower for things like SQL and Hyper-V. But for a user, every time they're saving the file and all this stuff, those IOs are really slow. Which means that scale-out file server is in many ways logically and in some ways sort of physically incompatible with end users doing stuff. Regular, Sally in accounting or Bob in sales. If they're opening files, closing files, creating new files, renaming files, they're using Office basically. Yeah, they are, they are. We won that battle at least. It's going to be a lot slower. It's going to be noticeably slower. If they're copying big, large files that they just, their summer and the Gold Coast videos that they store in their profile, that's going to be slower. And it doesn't matter. They don't need scale out. I mean, it sounds awesome. You're like, well, there could never be any interruption. I mean, I can just no longer any interruption. That sounds fantastic. Except the users really aren't being interrupted. They're using a regular cluster. When it's failing over nodes and the storage is coming back and the share is coming back, man, Office doesn't care about that. He'll just try it 15 more times. Then he's like, yeah, it's working. I don't know what happened. Okay. So just to recap on this, and then I'll dive into a little bit more IW stuff. This is a simple, single node file server. This is the lowest unit you can do. I've just got a file server. It's got some disks. It's got some shares. I got a couple of Hyper-V in a cluster connected to it. Maybe even just one. I don't know. It seems kind of silly and dangerous, but okay. And I don't even have to have continuous availability here. It's just one node, right? Who cares? Where else is it going to go? Dual node, or up to say like 8 node. Shared SAS or JBODs down there, hopefully using storage spaces. Somebody, please. Hyper-V, very inexpensive. You can scale to hundreds of disks with JBODs. Just a bunch of disks, if you don't know what that acronym stands for. It's just commodity storage. It's fast, it's very inexpensive. You can use, whatever type of RAID configuration you like, or if you use storage spaces with us, you're using our parity or mirror space technologies. Or you can do the multi-node, mega, thousands of disks, highest cost, but still, we think cheaper than most of the stand solutions. At that point, you're going to have to start using some fiber channel, as scaling up the number of JBODs is going to be very difficult. But it's only fiber channel down at the storage part, the very, very bottom. And you can use SMB always between, does this thing have a pointer? I don't know. Between the hypervisors and the storage clusters, or the storage nodes. Okay. Now, who here works in the cloud? Okay, 3 people. Of those 3, can you tell me what the cloud is? I'm still waiting myself. Okay. Who here works in on-premise, works in enterprise, medium business? Okay, I got the whole audience now. Anybody works small business only? No. They can't afford to come to this expensive get-together. Okay. Enterprise IW is where I've spent the last 15 years. It's where you've probably spent your entire career. It is, despite the best efforts of every network and trade rag out there, still where all the money gets made right now, where all the business gets done. Cloud's coming. There's no doubt about it. No doubt about it. But even when we rebranded ourselves recently, amongst our endless series of crazy news we keep putting out, we bought Nokia, we got a new CEO, is we call ourselves Cloud and Enterprise. We made sure to leave Enterprise on there because it really is still our bread and butter. And the on-premise information worker, the IW, is still where everything gets done. It's going to be a while before everybody can start transitioning or doing hybrid. Most likely hybrid will be where you land, or has any implementations of cloud. And some of the recent news actually kind of kicks cloud in the teeth, right? I mean, nobody wants to talk about cloud and then talk about complete access to anybody who wants the data from some nasty government organization. So, That means that businesses are still run on home folders, unstructured data. Our estimates from some of our little, field groveling people is 800 petabytes and growing. Anybody go to the work folders presentation? Yes. That feature is IW, right? I mean, that's designed for that's a brand new feature that took an entire team offline to work on it for a year, who only focused on a feature that was for enterprise. We still believe in the enterprise. And their entire mantra was, if there's 800 petabytes of user data sitting around out there and it's growing, we cannot give up on things like work folders and users accessing their files. And they're right. And I don't know if you've seen Windows 7 lately, but it's everywhere, and you're probably all running it. It can't be stopped. It's the new XP. And until it's gone, you're going to have a lot of people who are on the enterprise side because it doesn't really have any capabilities to do some of this stuff. And 2008 R2 is the same way, right? So, what does that mean to you? Oh man, I gotta hurry up. SMB 2 and 3, these pieces here are helpful to you. Despite all my cloud hoster app data stuff there, these things work for anybody. Encryption, signing, file leasing, which is a way for us to quickly access data without using horrific op locks. Energy efficiency. Oh, if your machine wants to go to sleep, SMB 2.1 and later lets it go to sleep. I mean, stupid stuff like this we should have been doing the whole time. Multi-channel. All those pieces are just from SMB, and then all this other stuff in the file server stack is for you too. Work folders. If you didn't go to that presentation, definitely go watch whatever it gets on Channel 9 or whatever. It's cool. I mean, it's really cool, and everybody wants it and loves it. RMS, DFSR, I did a big presentation on that yesterday. We added a bunch of new features. It scales to 100 terabytes, 120 million files. We cut the initial sync time down by 99.6%. We're not giving up on this stuff, I'm telling you. iSCSI, NFS, DAC. Anybody use DAC yet? Besides the PFEs. Anybody use DAC yet? Dynamic access control. Oh, I want to use claim-based auth, or I want to deploy my security to all my servers at once. I want to change the security and not modify any files. It's a lot of sick stuff there. All enterprise and IW related. Storage spaces, store simple, branch cache, direct access. Direct access is the #1 inside of Microsoft support requested advisory case right now. So we have this sort of quarterly thing where we're trying to figure out who's using what. Direct access is the one getting the most questions right now. It's getting the most traction right now. That one is it's an enterprise feature. It's a VPN replacement. FCI, traditional cluster, all those things are there in the regular file server stack for you to use right now. You'll never see a cloud and still be using all of these. And SMB 2.1, its performance and its pieces are nothing to roll your eyes at or hold your nose up against. So HP did a great study for us, and they're trying to sell some stuff too. That's fine. Showing how great 2012 and Windows 7 are using their file servers. So this is these are model numbers down here. The Store Easy and these B70 whatevers are flavors of it. And they're using FSCT, file server capacity tool, to say how many users they can hang off of one file server with home folders where the users are doing stuff with Office all day long. 26,000 users. That's a lot of users. Even if you get down to the middle of the road there, 9, 8, 10,000 users on one file server. You couldn't do that on 2003 at all. If you have not used FSCT, has anybody not heard of FSCT? It's okay to not have heard of it. It lets you validate your hardware, figure out what your performance bottlenecks are, tell just like I just bought this, I just got this demo machine from Dell, let's see what it can do. lets you see the number of ops per second or the number of users, where basically our threshold is about if the number of users before we get above 25 or 30% CPU, because we want to have plenty of leftover for whatever. Free download, get it anytime. Got a very simple setup. Okay, I have to go a little bit quicker now. So, we added one other feature. This is the first feature I ever owned when I came to the product group, called SMB diagnosability. Has anybody, before I show this, has anybody done troubleshooting of SMB in the past? I mean, pretty much everybody probably has had to, right? What are your usual tools for the job? Network monitor. That sounds like fun. Any good event logs for this? I'm sure the error messages are great. File not found. Yes, I knew that already. Access denied. Well, that's very, very helpful. So, the first thing that I worked on when I came to the product group was, all right, let's get serious. If we're going to bet everything on SMB, we should be able to troubleshoot SMB. And if the hypervisor is giving us some cockamamie, I can't start the VM error, and the cluster is just saying, I don't know, everything looks fine to me, we need to be able to tell at our layer what is going on. That means we need to be consistent in how we write our events. We need to take a look at all the scenarios we're trying to figure out and all the architecture and provide that information. So I shouldn't have to get a network capture. I should be able to look at the event log on client and server and say, like, all right, it's roughly the same time. This event says it was the client. This event says it was the server. These are the opposing events. What the heck happened? Sort of like a network capture in a box. I shouldn't have to turn anything on. Nothing makes me more happy than telling a customer, oh, you've had a gigantic outage? Well, turn off this logging and have it again, please. If they're thrilled about that. Make sure that we have all the details, all the troubleshooting guidance. My mantra was if you have to leave the event and go online, then we kind of failed on the event. Don't write so much that we wrap all the time. And does anybody use the BPAs? Oh, you're a liar. You guys don't even use it. Nobody uses the BPAs. Well, you probably do, Wayne. The BPAs are a great idea that unfortunately just get lost in the shuffle. Well, if I've got problems, here's two problems with BPAs. One, you run it, it tells you to do stuff, you ignore it, you move on. You run it, it tells you stuff is wrong, you don't notice it, you move on, or you don't run it at all. Then you have some problem or whatever, and the BPA was telling you all along, like, hey, you kind of messed up here a little bit, this is not optimal. And then you go and talk to somebody, you're like, I give up, let me talk to Microsoft on this, I'm paying all this money, I might as well get those jokers to do something for me. And they say, well, I don't have any data about how this is configured, give me all this data. All right. Well, shouldn't we just take best practices and make them something that we evaluate when you start up the machine? That's what we do now. In the server and the client of SMB, the broad areas of stuff where we say, like, that's really not a great configuration you've done there. We have events for those as infos or warnings, depending on our level of severity, just to say, like, and it's not noisy, it's at boot up, it's at service start. So, you've set insane, like you've turned off security completely? That doesn't sound right. You disabled multi-channel? Stuff like that. You end up with things like this. This event tells you as much as it can possibly tell you about the client. This is a server event telling me all about the client, the path, the share, the error was access denied to the share, exactly what the error was, the security descriptor that was used, and you'll have to keep scrolling, you can see the bar there goes down a ways. This is why it happens, this is what you might have done wrong, this is the place to go look. Come back later when it's all fixed. That's the idea behind this, and we are now trying to take this sort of mantra throughout the entire file server stack. Okay, so troubleshooting. Most of the SMB settings are in Server Manager, which doesn't help you on the client so much. But all of the SMB settings can be exposed through PowerShell. SMB share is the module. If you look at the SMB client configuration, get SMB client configuration, get SMB server configuration, or share configuration, it will tell you all the settings and all the knobs and all the things in scale out and multi-channel and RDMA and all those pieces that you could turn on and off and turn and flip and touch. If you're troubleshooting what you suspect to be an SMB problem, you can use those quickly to tell you if stuff is on or off. Oh, multi-channel's not working. Oh wait, Bob turned off multi-channel. When you're working on something as big and complicated as a scale-out application data cluster, you've got two clusters, you've got a hypervisor, you've got storage, you've got CSV, you've got the back end, you've got the network. Is it actually an SMB problem? Is there some quick ways you can validate that SMB is working at all? Can I use things like SQL I/O? Can I use things like dir? Can I open a folder? Can I access a file? Can I ping the machine? Is it the storage? A lot of problems. We made sure in the eventing that I was on the other page, a lot of the eventing can't tell you in SMB land, oh man, the storage is messed up. But it can tell you that it thinks it is. He can't tell you exactly what's wrong with that storage space, which is super degraded on perf because like half the disk just died, because who knows why. But it can tell you that I'm getting really slow I/O right now from the storage system. You should go check out the storage system. Things like that. Even when it is SMB, it might not be SMB. The network. So I'm having an SMB problem, but I'm having it because the network is flaking out. I'm having an SMB problem because, like you saw in that event, security. I don't have access to the data. We have an enormous number of logs now that we do a terrible job of advertising. Let me just cut over here real quick and show you. Someday. Wake up. There we go. This is my client, right? I've got a system event log. I've got SMB client, SMB direct, SMB server, witness. These have, oh, it's a security issue? Go look in the security log. Well, you can't connect? Go look in the connectivity log. It was working and it broke. Operational, or not operational log, as I call it. On one of these cluster nodes, wake up. No. Do you guys get to see the whole, like, I can copy and paste between VMs thing? That's so sweet. The only thing sweeter than that is the level of embarrassment that it took us that long. Don't tell Ben Armstrong. I know he's around here somewhere. Don't tell him. He's one of you Australian guys. He'll kill me in 2 seconds. All right. What was I doing? Oh, the events. Event viewer. Wait, did I type that right? Yeah. Over here I've got CSV logs. There are storage spaces logs. There's cluster logs like you wouldn't believe. There's the SMB server pieces here. Let's see if anything interesting happened on SMB server lately. Probably nothing in connectivity, very little. Operational. Yeah, there's an endpoint coming online. All these things will have explanations of, you know, some of the more esoteric things. What do they mean? Don't worry about it. That's my favorite thing to encourage people. thank you, is you don't need to do anything. This is just to let you know that it worked out okay. Something big happened, but it worked. Anti-events. All the time we have no strategy for event logging, trust me, as a company or as an organization in Windows. It's for every man for himself. So you need to be able to use these kinds of events to let you know, it's working great. I fixed it. I'm down just a couple of minutes here. My personal favorite coming from Microsoft support. You're using a complex multi-vendor solution. I have never met a storage vendor in my life who's ever had a single problem. Never. But of course they did, right? The same way that we do. Everybody's got problems. Pin them down. Make them prove that they're working, not that they're failing. Message Analyzer. Anybody using this? A couple. This is the replacement for Netmon. Oh no, replacement for Netmon. But it really is a great tool. And it's designed it's specifically got well, they don't call them parsers anymore, but the tracer thingies, I don't know what they're called. Like specifically for SMB3. In fact, it's got its own entire chapter basically and its own pieces and tracing and aspects that are just for SMB troubleshooting. So you guys look through all this giant capture about a bunch of crap you don't care about. This is just the SMB parts. The protocol usage, the errors, the conversations. I don't know if I have time to show it. You can download it from here. And it really is, if the event log fails you, he will save you. And I kind of cut ahead through my demo already. This will show you, no matter who the vendor is, no matter how you think things are configured, is this stuff on? Persistent handles, directory leasing, multi-channel. Is large MTU turned on? Is leasing turned on? Is encryption turned on? All those things. You can set stuff in the settings all day, whether or not they're being used, whether or not your vendor has actually, does my vendor support doing SMB encryption? They don't say they do, but I mean, maybe they do. You can find out for sure. Finally, my last piece. Please do not get into the habit, as so many people have, of starting off your troubleshooting of SMB 2 or 3 by turning it off. I really mean it. There are lots of times when you're gonna find articles on the interwebs or even on Microsoft that I've carefully scrubbed, but they come up there, little whack-a-moles, that say, turn off SMB3 and fix your problem, usually with your user application problem. Not typically with anything else, but usually your user using some app. There are settings here that are probably the real problem. Cache timeouts for file info, directory metadata, and file not found. You can tune those. You can turn them off. That fixes about 99.9% of those issues. The downside is you get slower. They're all designed for performance. Once you find yourself changing these, go find that vendor, beat them up. Even if it's not their fault, make them beat us up for whatever we did wrong that broke them. That's happened too. We've done bug fixes via the customer through a vendor. But oftentimes it's just they're doing some crazy stuff, make them fix it. If you do, and I know you're going to turn it off sometimes, it's too much pain otherwise. If you do, use it as a test. Don't use it as a solution. All these features we keep piling on SMB, you know how it is in a big enterprise, right? You start turning things off, and then after a while, the guy who did that's gone, and you inherit something, and then eventually you're trying to use SMB3, and it's not working, and you're like, what jackass turned off SMB3 everywhere 3 years ago? Don't be that guy. I'm getting recorded again. Okay. Some of these have already been. Some of these might be in the future. There's a ton of content here for you. A ton of content. You don't have to remember any of this stuff. It's all out there. You can apparently win a mouse. I'm all out of time. Thanks very much, guys. Enjoy the rest of TechEd.